The screens went blank at 4:14 in the morning. Not one screen. Every screen. Every tracking station. Every antenna in the deep space network that had been locked onto the Orion capsule for 10 days straight, following it to the moon and back, receiving its heartbeat of telemetry data every second. Temperature readings, pressure readings, the pulse rates of 4 living human beings. All of it vanished simultaneously. Mid-sentence, mid-number. The signal didn't fade or degrade. It simply stopped, the way a phone call stops when someone on the other end ceases to exist. One moment the data was there, the next moment there was nothing. And in mission control at NASA's Johnson Space Center in Houston, in a room full of the most technically sophisticated people on Earth, surrounded by more processing power than existed anywhere in the world 50 years ago, nobody knew whether the 4 astronauts they had spent 10 years training and 10 days monitoring were still alive. They wouldn't know for 13 minutes. 30 minutes is not a long time by most measures. It is the length of a pop song and a half. It is how long it takes to soft boil an egg. It is the amount of time most people spend scrolling their phone without noticing. But 13 minutes is also exactly how long a human being can survive without oxygen before irreversible brain damage begins. It is roughly how long the Titanic took to sink below the surface after its final plunge. And on the morning of April the 10th, 2026, it was the precise window of time during which 4 astronauts returning from the farthest point any human being had ever traveled from Earth were completely, totally, and deliberately unreachable by anyone on the planet they were hurtling toward at 25,000 miles per hour. This is the story of those 13 minutes, what caused them, what was happening inside the capsule while they lasted, and what it means that we still, after everything, choose to do this. The Orion capsule named Integrity had been in space for 10 days. Commander Reed Wiseman, pilot Victor Glover, mission specialist Christina Koch, and Canadian Space Agency astronaut Jeremy Hansen had flown farther from Earth than any human beings in history. 252,000 miles, a record that had stood since Apollo 13 in 1970, and that nobody had come close to touching since. They had orbited the moon. They had seen the lunar far side with their own eyes, the side that faces permanently away from Earth, the side that human civilization had never seen until a Soviet probe photographed it in 1959. They had made calls from deep space that reached the International Space Station, and a watching world with a delay that reminded everyone listening exactly how far away they were. And now they were coming home. The mission was essentially complete. The dangerous parts, everyone assumed, were behind them. Everyone was wrong. But here's the problem. The most dangerous 8 minutes of the entire mission were not the launch. They were not the engine burn that sent the capsule around the moon. They were the last 8 minutes. The re-entry. The moment when 10 days of careful engineering and precise navigation compressed into a single violent transaction with the Earth's atmosphere. A transaction that had only 2 possible outcomes, and only one of them was acceptable. Re-entry from the moon is categorically different from re-entry from low Earth orbit. When the space shuttle came home, it was traveling at roughly 17,000 miles per hour, fast enough to be extraordinary by any human standard, but manageable within the physics that aerospace engineers had spent decades mastering. Integrity was coming in at 25,000 miles per hour. That additional 8,000 miles per hour is not just a larger number. It is a fundamentally different physical event. The kinetic energy a spacecraft carries is not proportional to its speed. It scales with the square of speed, which means Integrity, compared to a shuttle re-entry, was not carrying proportionally more energy to shed. It was carrying nearly twice as much energy per unit of mass, twice as much heat to generate, twice as much deceleration to survive, twice as much of everything that makes re-entry the most violent thing a human being can do and come back from. The capsule hit the discernible atmosphere 75 miles above the Pacific Ocean. At that altitude, the air is barely there, barely more than a suggestion of molecules scattered through near vacuum. But at 25,000 miles per hour, barely there is enough. The compression begins immediately. The molecules in front of the capsule have no time to move aside. They stack up, compressed by a blunt wall of metal moving faster than the speed of sound by a factor of 32. And that compression generates heat in a way that goes beyond what most people understand about friction. This isn't rubbing 2 sticks together. This is a shock wave, a bow of compressed, superheated ionized gas that forms in front of the capsule and wraps around it like a second skin, made of something that no longer qualifies as matter in any ordinary sense of the word. And this is where things change. When gas gets hot enough, and the temperatures generated around integrity during peak heating exceeded 5,000 degrees Fahrenheit at the heat shield surface, with the surrounding air reaching nearly twice the temperature of the sun's visible surface, the molecules stop being molecules. The atoms stop being atoms. The electrons that normally orbit their nuclei in tidy quantum arrangements rip free. The gas becomes plasma, the fourth state of matter, a seething, electrically charged soup of stripped nuclei and free electrons that glows with a light so intense it would blind you to look at directly. And plasma does something that ordinary gas does not. It blocks radio waves, not weakens them, blocks them. The plasma sheath surrounding integrity during those 8 minutes of peak re-entry was dense enough and energetically active enough to absorb and scatter every radio frequency that NASA's tracking systems were transmitting and receiving. The capsule was not just far away and hard to hear, it was encased in a material that radio signals physically cannot penetrate. Communication didn't degrade, it ceased. The laws of physics closed the door, and the door had no handle on the inside. At 4:14 in the morning Pacific time, Mission Control lost the signal, and they waited. But it gets worse. Inside the capsule, the 4 astronauts knew this was coming. The blackout was planned, expected, calculated to the second based on the re-entry trajectory NASA's engineers had designed. But knowing something is coming and experiencing it are separated by a distance that no amount of training fully closes. What the crew felt in those 13 minutes was not simply the absence of communication. It was the presence of everything the communication had been shielding them from knowing too directly. The vehicle was oscillating, controlled oscillations managed by a guidance computer making thousands of adjustments per second to the orientation of the capsule, using the lift generated by the blunt capsule body to modulate the heating rate and the G-forces pressing into the crew's chests. But controlled oscillation inside a plasma fireball traveling at Mach 32 does not feel controlled. It feels like the universe reminding you that it does not negotiate. The G-forces during peak deceleration pressed into the crew at levels that turned their own body weight into a crushing presence. Breathing required conscious effort against the compression. The sounds inside the capsule, the groaning of the structure, the roar that penetrated even the heavily insulated crew compartment, were sounds that no human being had heard in over 50 years, not since the last Apollo crew came home in 1972. And outside the windows, visible through the small portholes not facing the heat shield, the plasma glowed, orange and violet and white, a light show of destruction that was also, from the outside, breathtaking. From the inside, it was simply the visual confirmation that the thing keeping them alive was actively sacrificing itself to do so. The heat shield works by dying. That is not a metaphor. The Avcoat material covering the 16.5-foot base of integrity is designed to absorb thermal energy and char, to transform its own molecular structure under the heat, to slowly erode away, carrying the thermal load with it into the slipstream. Every fragment of material that burns off the heat shield is a fragment of temperature that did not reach the crew compartment. The heat shield gives itself up so that the people behind it can survive. And during Artemis 1, the uncrewed test flight in 2022, that sacrifice had gone wrong in ways that took NASA 2 years to understand. More than 100 locations on the recovered heat shield showed unexpected damage. Chunks had sheared off not because they were designed to, but because gases trapped inside the material had built up pressure and blown out, taking protective material with them. The capsule had survived, but the margin had been smaller than anyone had designed for, and smaller margins in spaceflight have a specific historical meaning that nobody in the program needed to have explained to them. But that's not even the worst part. The heat shield on Integrity was the same design as the one that had failed on Artemis 1. Identical formulation. NASA had ordered a new design for future missions, but replacing the shield already installed would have delayed Artemis 2 by 18 months or more, so instead they changed the trajectory. They modified the skip, the way the capsule dips into the atmosphere, briefly rises back out, then commits to final descent. To keep the outer char layer permeable throughout re-entry, to give the trapped gases a path to escape rather than building to the pressure that had blown chunks off the previous mission. The modification was based on analysis, on simulations, on lab tests designed to replicate conditions that cannot be fully replicated on Earth because nothing on Earth moves at Mach 32 through a plasma sheath while carrying 4 living people. A former NASA astronaut and engineer named Charles Camarda said publicly, before the mission launched, that the root cause was not fully understood, that flying people on this heat shield was an unacceptable risk, that the analysis was insufficient. NASA disagreed, launched anyway, and put 4 human beings behind the heat shield with a documented failure history into the most thermally extreme re-entry an American crewed spacecraft had attempted in the modern era. In Houston, the controllers watched blank screens and waited. In the Pacific, tracking ships pointed their antennas at the sky and heard nothing. In mission control, someone was watching a clock. 30 minutes is not a guess, it is a calculation. Based on the re-entry trajectory, the altitude, the velocity, the atmospheric density model, the expected duration of peak plasma heating. Engineers had calculated when the signal should return. They knew to the second when they expected to hear from Integrity again. And in those final seconds, in the gap between when the math said the blackout should end and the moment the first signal either arrived or did not, the room held something that no instrument in that building was designed to measure. At 4:27 in the morning, the signal returned. Not gradually, not weakly. The telemetry snapped back into existence the way it had disappeared. Completely instantly, all of it at once. Temperatures nominal, pressure nominal. 4 heartbeats on the biometric displays. All of them elevated in the way that hearts are elevated when the universe has just spent 13 minutes reminding you what it is capable of. The crew was alive. The heat shield had held. The trajectory modification had worked. The math had been right. 11 parachutes deployed in sequence over the next several minutes, slowing the capsule from supersonic to survivable in a series of jolts that the crew later described as violent and glorious at the same time. The USS John P. Murtha was waiting. Recovery swimmers reached the capsule. The hatch opened. 4 people stepped out into the cool Pacific morning air and breathed it with the specific quality of breath that